Bismillah ar-Rahman ar-Rahim. This is teacher Iman solving today exercises on chapter 7 integration on 7-1 the definition of the finite integrals and theorems on the finite integrals, all done by teacher Iman al-Khadi. The first question is saying evaluate the following by using the definition of the finite integral. Let's have the first a from 0 to the 3 2x dx. To solve that and evaluate it, you are going to use the following definition, which is equals to the limit when n approaches to infinity for the summation I equals to 1 till n delta xi times f of xi, where delta xi is the width of any rectangle and f of xi is the length of any rectangle. And we are going to multiply them to each other, then find the summation for their area, then make n goes to infinity to make the number of rectangles more and more and more till infinity. Now to solve this or to use this definition, because this is the definition which we call it, the definition of d-finite integrals. Look, it's d-finite. D-finite, that means has lower limit and upper limit. So here the definition is that one. To find it or to use it, you are going to start by finding the width of this rectangle by using the following rule, which is b minus a over n equals to 3 minus 0 over n equals to 3 over n. As we said, b equals to the highest number, and a you can take it from the lowest number in the integral, and that will make it 3 minus 0 over n, and that will make 3 over n. And the n is the number of rectangles, which is unknown always. To find the length now, you need to find xi first, which is can be found by the following rule. A plus b minus a over ni equals to 0, because this is the value of a, plus 3 over n, which going to be taken from here, multiplied by I equals to 3 over ni. Then take the value of x and xi, and replace it in the whole function. That means you are going to multiply it here by 2. This is how to replace it. F of xi equals f of 3 over ni equals to, look, we multiply it by 2 to make it 6i over n. Remember, don't multiply 2 down, only multiply it by the numerator. Now you got the width and you got the length. To get the area, you are going to multiply them together. Like that, 3 over n multiplied by, which is coming from here, 3 over n, multiplied by 6i over n, which is coming from here. And if you multiply numerators together, you will get 18i over n times n, which is n squared. This is the area for each rectangle. Now we need to add them all by using the summation, which we call it Riemann sum. From 1 till n delta xi multiplied by f of xi by using the properties of summation, which can allow this summation to let that constant term to go outside as a common factor, exactly like that. 18 over n squared summation for I, and we have a rule for summation of I, or a property, which is a property number 4. So let's use it now. 18 over n squared is still constant. We are using property number 4 of summation of I, which is n times n plus 1 over 2. Now you can cancel as you can. 2 with 18 will give you 9. N up with n squared down will give you n down. And that all is still multiplied by n plus 1. Do your simplification as you want. That all equals to the limit when n approaches to infinity, and this is the last step to do the definition or to use the definition to find the finite integral, which gonna be for the whole thing. So you're gonna let the limit get in for that answer, which is 9n over n plus n over n. By canceling n with n and replacing it infinity instead of n, you will get finally the value of 9. It is exactly like that. 9 plus 9 over infinity equals 9 plus 0 equals 9. So the value is 9. This is how to evaluate it. Let's have another example, which is in B. from 1 to 5, 2x plus 3 dlx. To find its value by using the definition, you have to write the definition. So the definition exactly like that. Limit when n approaches to infinity for the summation I from 1 to n for delta xi, which is the width, multiplied by f of xi, which is the length. Now you have to follow the steps, and they are six. You're going to find first of all the width, which is delta xi, by using the rule b minus a over n. We are repeating the steps. Equals to, take care, b is the highest and a is the lowest, which is 5 minus 1 over n, which is going to give you 4 over n. Now to find the length, you need to find xi first by using the following rule, which is a plus b minus a over ni. A is given, which is 1 now, and you can replace it, and b minus a over n, you get it here, which is 4 over n. So use it and then multiply it by I. Now to find the length, you are going to take the whole thing here and you try to replace it instead of x. That means you're going to multiply it by 2, then add to it 3. Let us see how. Exactly like that. We are going to multiply the whole thing by 2. The whole thing you multiply it by 2 and add it to 3. Now open a bracket. 2 multiplied by 1 is 2. 2 multiplied by 2 by 4 is 8. 8 over n, don't multiply by n. And li beside. And that all plus 3. Don't touch 3 and multiply with. Keep it alone because it is outside the bracket. Now try to add like terms to get a 3 plus 2. 3 plus 2, which is 5, plus 8 over ni. Now you got the length and the width. Let's multiply them to get the area for each rectangle, which is from here 4 over n multiplied by that one, which is 5 plus 8 over ni. Multiplying length by width. Length by width. Then add them by using the summation. The summation of the width multiplied by the length will give you a 20 over n plus 32 over n squared I. According to the properties of the summation, you can let the summation get in for each and take care about if you have a constant. Anything has no I means it's a constant. Anything without I, it is a constant. So this is a constant. So any constant, according to property number 1, will be changed to a constant multiplied by n. So this is the first property application. Now let's go to the second one, which is 32 over n squared. It is a constant also because it has no I. Goes outside as a common factor and the I stays because it is a variable. Now we have a rule for summation of I, which we're going to use it now, which is n times n plus 1 over 2. Now try to cancel as you can. N here with n there can be cancelled. Here also, this summation will give us that rule, so I can cancel this n up with that n squared down to get n down. And 32, if you divide it by 2, you will get 16. So you'll get finally, after simplification, 2 plus 16 over n multiplied by n plus 1. Try now to find as simple as possible the following. A 20 plus 16n over n and plus 16 over n. That will make these together cancelled, and 16 plus 20, it is 36 plus 16 over n. Now it is the time for the last step in this definition, which is taking the limit. So the limit of the whole thing will be like that. Limit for a constant number stays. And if you replace an infinity instead of an n, that will make it 0. So we will get rid of 16 over infinity to make it 36 only, which is the value of our integration, definite integration. Now we can have more. Let's have that example, which in a different way. It proves that integration from 1 to 2 to 2x minus 4 dx is smaller than or equal to 0. Actually, you can prove it in different ways. You can sketch it. You can have a number, replace it instead of an x to be sure it is less than 0, that's mean negative. You can, for example, build the function. I think now we are going to build the function. So if we want to build the function, we are going to make an x between 1 and 2. From here, we get them from here, from 1 till 2. From 1 till 2, this is my x. And according to my function, I can see that the x is multiplied by 2. So I'm going to multiply each side by 2. And then we need to subtract each side by 4. Then we need to integrate each side from 1 to 2 by using the theorems for integration. So come on, we are going to use the steps in that way. Multiply by 2. If you multiply by 2, you will get 2 here, 2x there, and further subtract by 4 to get how much? 2 minus L4, 2x minus L4, and 4 minus 4, which will give you negative 2 here, smaller than or equal to 2x minus L4, which is going to give you the function completely now. And that all is smaller than 0. Now let the integration get in for each. Or no need, just you are going to think about 2x minus L4. It is smaller than or equal to 0. Because it is smaller than or equal to 0, that means the whole function is negative. The whole values of function is negative. So we can say that, therefore, we found that 2x minus L4 all is smaller than or equal to 0 for all values from 1 to 2. From 1 to 2, the function all is negative. That means if the function is below the x-axis and it is negative and each value inside it is negative, so the integration of it is going to be negative also. So this is from the theorem. The theorem said that if the function is negative, its integration is negative. If the function is positive, its integration is positive. So it is theorem. Now let's have another example. Oppositely, we are going to prove that the function is bigger than or equal to 0 to prove that the integration is positive. We can say that you can prove it in different way also by sketching the graph, by building the function, by choosing a number between 1 and 3 and replace it in a set of x and prove it will give you positive always. So you have many ways to prove it. Now let's have building the function, which can be started by x between 1 and 3, which you can read it by x bigger than or equal to 1 and the x is smaller than or equal to 3. Now, according to your function, you can see that your x is squared. So you need to square each. And you can see that everything is subtracted to 1. So you can subtract by 1. Now, square each. Nothing going to be changed because each are positive. So 1 square, x square, 3 square, and keep the inequality symbol as it is to make sense. That will give you finally x squared bigger than or equal to 1, smaller than or equal to 9. Please make sense that your step here is right. Now, you need to subtract by 1 in each from the question. It is here subtracted the whole x squared by 1. So you need to subtract by 1, and here subtract by 1, and here subtract by 1 to get the following. 0 smaller than or equal to x squared minus L1 is smaller than or equals to 8. Now, did you get the whole function completely written? Yes, you did. It is here x squared minus L1 and it's 6x squared minus L1. So you can stop and you try to see if your function all bigger than 0 or smaller than 0. You can see it is bigger than 0. Ignore that part. You need to focus on that part only, which telling you that it is bigger than 0. So you can write it. Therefore, x squared minus L1 is bigger than 0 or equal to from 1 till 3. That's mean if the function is bigger than 0, if it is positive, full or values from 1 to 3, and it is above the x-axis, that means its integration, its area is going to be bigger than or equal to 0. So this is from the theorem also. Now let's have another idea and another exercise. Which one is greater? We can also compare between integration from 0 to 1 to square root of x dlx or integration from 0 to 1 to x squared dlx. As usual, we see that you have many ways to solve. You can choose numbers between 0 and 1 and replace it here and there to check which one is bigger. Or you can sketch each. Or you can build a function. Or you can do whatever. Let us see some ideas. Here, we can build the function for each. For example, I can start at x between 0 and 1 and try to multiply each by x. Like that exactly. If you multiply this by x, you will get 0. This will give you x squared. This will give you x. And if you're going to take a square root for each, you will get 0 here, smaller than or equals to square root of x squared, square root of lx. And now that will give you finally 0 and smaller than or equal to x smaller than or equal to square root of lx. Now compare between square root of x and x. Now, we finish building the first one. We need to compare between number 1 and number 2 because we need to compare between x squared exactly. It is smaller than x. And square root of x is bigger than x. If we're going to reorder them in one inequality system, we will get the following. From 1 to 2, you can see that x, it is in the middle, which is bigger than x squared. Watch it. X is bigger than or equal to x squared. And again, x is smaller than or equal to square root of x, which is exactly like that. So you can build that function to say that x squared is smaller than square root of x. X squared is smaller than square root of x. So that will give you if x squared is smaller than or equal to square root of x for all x belongs to the interval from 0 to 1 because we start our interval from 0 to 1. And this is important. Then if a function is smaller than another, so its area gonna be smaller than the other. That makes sense. So the integration from 0 to 1 for x squared dlx, which is the smallest, gonna be smaller than or equal to the integration from 0 to 1 for square root of x dlx. Now let's have another example. We proved it. If you want to prove that integration from negative 1 to 0 with the cube root of x dlx, is it bigger or smaller to the integration from negative 1 to 0 for the fifth root of x dlx? Also, you can use any way you would like to. You can choose a number between negative 1 and 0, replace it in each, and try to compare between them to see which one is bigger. Or you can sketch each, or you can follow the following way, the building the function. So here you can start your x between negative 1 and 0. Then you need to square both sides. If you square them, remember the idea. We said that if you have an x between negative and positive, you are going to square each and make that side positive because the x squared always positive, always bigger than or equal to 0. And that side will take the square of the highest number, the square of the highest number, which is 1. Because if you're going to square negative 1, you will get 1. And if you're going to square the 0, you will get 0. So it makes sense when you are writing your inequality. Now multiply by x cubed. Why? To get x5. So this is the idea. You will get now 0, x2 times x3, add the powers to get 5. 1 times x3, it is x3. So we are multiplying each by x3. Now, to return it back as roots, we are going to take the LCM between 3 and 5, which is 15. So take the 15th cube to get rid of these powers. That means you will make it in that way. Look, we are taking 15th root, 15th root, 15 roots for each. That will make it exactly as 5 over 15 and 3 over 15. And if you cancel these powers, you will get finally x to the power of 1 over 3 smaller than or equals to x to the power of 1 over 5, which can be written in that way. The cube root of x is smaller than or equals to the fifth root of x. Now we get the point. We know that cube root of x is smaller than fifth root of x. That means if a function is smaller than another, so its area is smaller than the other. So that means if you're going to let the integration get in for that interval from negative 1 to 0, so we will get the integration from negative 1 for 0 for the smallest area will be smaller than or equals to the integration for the biggest interval or a region, which is for fifth root of x dlx. So we proved that this one is smaller than that one. It's proved. Let's have another idea, which is with example or exercise number 4. Prove the following. We need to prove this function from 1 to 2, x squared dlx is smaller than or equal to the integration from 1 to 2 x cubed dlx. You can see that always when we are comparing between integrations, The limits should be the same. If they are not the same, you can't use these theorems. You can't apply these theorems. You are going to evaluate each alone by using the coming ways. We didn't explain it till now. But till now, we are going to use the theorems, which are the 10 theorems of the finite integrals, if we have the limits from here to there are similar for the limits from here to there. If they are not, you can't use the 10 theorems. Now, let's build the function like usual. We can build the function from x between 1 and 2. After you multiply each by x squared, you will get exactly 1 times x squared is x squared. X times x squared, by adding the powers, you will get x cubed. 2 times x squared, you will get the 2x squared. Now, you are going to compare between x squared and x cubed. This is what we are looking to compare between. And if you compare between them, you will find x squared is smaller than x cubed. And if you sketch them, you will see that clear. Now that all from 1 to 2, its domain. That means if any function is smaller than another, the region of the first, its area going to be smaller than the area of the largest region, which is from 1 to 2 for x cubed dlx. It's proved. Let's go to the next. We can have b from 0 to 1 for cube root for x dlx is bigger than integration from 0 to 1 for square root of x dlx. How to prove that? Also, we said that you can sketch it in a graph and compare between them, or have a number between 0 and 1, simplify, substitute it between or in each, and compare between them to see which one is bigger. Or you can build the function. Let's use building the function now. X between 0 and 1. Multiply each by x squared. Let us see how. 0 times x squared is 0. X times x squared is x cubed. 1 times x squared is x squared. Now let's take the fixed root of each. Let's take that. Here is 0, it's a cube, its sixth root is the same. This one exactly going to be written in that way. You're going to divide a 3 by 6, and here you're going to divide 2 by 6 to get the value. And that will give you easily 1 over 2 is smaller than 1 over 3. And what is 1 over 2? It is the square root of x. And what is 1 over 3? It is the cube root of x. So you found that a square root of x is smaller than or equals to the cube root of x. That means this one is smaller than that one. And a cube root of x is bigger than a square root of x. That will make their integration bigger, because integration means calculating area. So if that function has a small region than that function from 0 to 1, and you can check this by sketching the graphs, and that means the integration from the first is going to be smaller than the integration from the second. It's proved now according to that theorem. Let's have other ideas in this exercise. Number 5. Find the lower and the upper limits of each of the following integrations. We're going to start by A from 1 to 2 x squared plus 1 dx. You need to build the function. Here you have to. It's better for you than other ideas. So come on. You are going to build a function from 1 to 2. Then think about x. It is squared by 2 and added by 1. Then you're going to integrate each side and use the theorems of integration. Now, if you square each, you will get 1 square, x square, and 4. Nothing going to be changed in the inequality symbol because we have no problem with the inequality, and it makes sense that 1 is smaller than 4. Now we need to add 1 to each. That will make it 1 plus 1 smaller than or equals to x squared plus 1. Smaller than or equals to 4 plus 1. After you evaluate them, you will get 2 smaller than x squared plus 1, smaller than or equals to 5. Then you need to integrate each. When you are integrating a constant with the finite, you are using a property number 1, or you are using the rule of number 1, which is I think it is theorem number three of the finite. So theorem number three, which is gonna keep the constant outside, then multiply it by b minus a. B minus a. So always when you are integrating a constant, theorem number three, you are going to keep 2, which is the constant number, outside and subtract b minus a. Now here, because you have a variable, keep it as it is, and this is your actually function that you need to build, completely written. Smaller than or equals to, always if you want to integrate again any constant, you're going to keep it constant outside, multiply it by b minus a according to theorem number 3. How much you will get now? You will get 2 times 1 according to this subtraction, written here, smaller than or equals to the whole middle integration, keep it because you can't do anything with it, smaller than or equals to 2 minus 1 is 1 multiplied by 5 stays 5. Now you are done and you got the lower term, which is 2, and the upper term, which is 5. So this is the answer that we are looking at from the beginning. 2 is the lower term and 5 is the upper. Makes sense when you are solving. Let's have another idea and we choose for you something with rational functions. We need to find the upper and lower term for integration from -2 to -1 for dx over 2x squared minus 1. The idea is you need to build the function. Make an x between -2 and -1. Be sure that you are starting by the smallest, then the biggest. Or make sense when you are writing them. Now you need to square them. We have here a property you have to take care about it. When you have negative and negative here and there, and you want to square each, you have to write it in that way. Watch it. If you have an x is bigger than negative number, and smaller than another negative number, that's mean if you square each, you will make x squared in the middle, and you are going to square here the lowest number. And here make it the highest number squared to make sense. Let us see how. You're going to say that x after you square it become x squared. -2 after you square it become 4. So you can't write it in its position. You have to change its position because it is the biggest. -1, if you square it, you are going to make it 1. So in that case, to make sense, it is from 1 to 4. And 1 is smaller than 4. So makes sense always when you are dealing with inequalities. Now, you need to multiply each by 2. Come on, 1 by 2 is 2. X squared by 2 is 2x squared. 4 by 2 is 8. Now we need to subtract each by 1, like that. 2 minus 1 is smaller than or equals to 2x squared minus 1, smaller than or equals to 8 minus 1. That will give you 1 smaller than or equals to 2x squared minus 1, smaller than or equals to 7. I think now we need to flip each. And the flipping will change the inequality symbol to make sense. That's mean 1 over 1 bigger than or equals to 1 over 2x squared minus 1 bigger than or equals to 1 over 7. Look, we are making sense too in this inequality. Because of that, after we flip each, we change the inequality symbol and we make 1 over 7 is smaller than 1, or you can read it as 1 is bigger than 1 over 7. Now, sorry. After you build the function, you are going to integrate each. Come on. Use theorem number 3 when you are integrating constant to make it exactly like that. This is 1 multiplied by -1, which is b, minus a. b minus a. And watch it. This is b, -1 minus -2, which is going to be +2. Bigger than or equals to integration from -2 to -1 dx over 2x squared minus 1. This is how to write the integration completely. Bigger than or equals to 1 over 7 multiplied by b minus a. b is -1, negative 2 become +2. That means after you subtract them, 2 minus 1 is 1. If you multiply it by 1 over 7, it stays as it is in each side. Now we finish our building the function and we can find the lower term and the upper term. The upper is 1, of course, makes sense. And 1 over 7 is the lower. So that makes sense when you are choosing them. The lower is 1 over 7 and the upper is 1. We are done with these and we can now have some object questions because we need it. Shade true if the statement is true and false if the statement is false. Let us see how the questions in ministry can occur. Number 1. Integration from negative pi over 4 till 0 for cosine x dx is smaller than or equals to integration from negative pi over 4 till 0 for sine x dx. How to compare between them? I told you. You can use many ways. You can sketch each and you try to compare between them by sketching, or you can choose a number between them, like for example, negative 60, no, not negative 60, negative 30. You can choose negative 30. That is easy to deal with and it is a famous number. So you can use it because you know that negative pi over 4 is negative 45. Now let us try. It's false because if you replace x equals to negative pi over 6, which is 30, in each you will get the following. Let us see. Cosine negative pi over 6, since cosine is an even function, negative gonna disappear. And that means cosine 30 is root over 3 over 2, which is 0.8. And sine negative pi over 6, it is negative, and the negative appears here because the sine is odd function, which is 1 over 2. Sine negative pi over 6, which is 30, is negative 1 over 2, which is negative 0.5. Negative always smaller than positive. So this should be smaller than that one. And this should be bigger than that one. So because of that, it is false. The other question. Number 2. Integration from 1 to 4 x squared dx is bigger than or equals to the integration from 1 to 4 for 2x minus 1 dx. To prove it, I told you, you can sketch a graph for each and compare between them. You choose a number between them, build the function. You have many ways to deal with. Let's now choose a number because that will be easier in the objective questions. It's a true because if you replace x equals 2 and the 2 between 1 and 4, you can choose a 3, you can choose whatever, you can choose 2.5, you can choose a 3 over 2, whatever you want. In each, replace it in each, you will get 2 square equals 4. This is when you are replacing it in the first. Now let's replace it in the second. And 2 times 2, negative 1, will give you 4 minus a 1, which is a 3. If you compare between 4 and the 3, you will get 4 is bigger than a 3. So that makes sense. It's a 3. In number 3, integration from 1 to 3, x squared negative 1 dx bigger than or equal to 0. That will make it a true or false. The way as you are going to replace a number between 1 and 3. Let's just choose 2, for example. If we're going to choose x equals to 2, you will get 2 squared negative 1 equals to a 3, which is bigger than or equal to 0. The number is positive. So if the number and the value of this number is positive, so the whole integration is positive. This means the function all above the x-axis. The upper term of the integration from 0 to 3 for ex dx is a 3. That means if you want to find the upper or lower, you need to build the function. And to build the function, you need to, uh, for example, start from x between 0 and 3. Then let this e get in for each, like this. E to the power of 0, e to the power of x, e to the power of 3. Anything to the power of 0 is 1. And this stays, and this is a constant number, just keep it. Now you need to integrate each. To integrate any constant, you're going to keep it as it is and subtract b minus a, like theorem number 3. And this keep it as it is because this is what we are looking to complete. And this is smaller than or equals to e3. It's a constant number. Leave it. Multiplied by b minus a, which is 3 minus 0. You will get finally here from this one 3 minus 0 is a 3 multiplied by 1 is a 3, which is the lowest. And just keep it as it is, and then you will get 3 minus 0 is a 3 multiplied by e to the power of 3. To get the 3e to the power of 3 is the upper. And he said that the upper is a 3 only. It should be 3e to the power of 3. This is the lower. Because of that, it is false. Thank you for listening, and I hope that you get the lesson. And if you have any problem somewhere, write your comment to me and we can discuss it later anytime. You are welcome for the next lesson, and we're gonna say goodbye.